Dhaka, Department of ECE, Institute of Science Present Technology, Dhaka. Now I am presenting paper ID 512, which is the topic is real-time IoT-based toxic gas monitoring, comparative analytic of machine learning technique for air quality index prediction in Dhaka. Let's go to the next slide. Here is the paper outline. I can explain this all of topics. Here is my paper abstract, which is the assessment of the machine learning language technique, which is the LRDA, DT, KNN, and SVM for predicting the air quality index in Dhaka. And we are mostly use the sensor-based system for the detecting for the ammonia, methane, and sulfur dioxide utilizing by the RDMO and many MQ sensors. And the superior performance is R square is a 0.999 and mean square error, which is the 0.4410, and root mean square error is 0.6641. Let's talk about the introduction. Mainly we focus the air prediction using the machine learning and IoT toxic gas monitoring, and we use this sensor for MQ4, which is the methane, and MQ4-135, which is used for the sulfur dioxide and carbon monoxide, and MQ136 for the ammonia. And we also use for the data source, which is the Galaxy AQI dataset in 2016 and 2022. And we also use the machine learning model, which is compared to the ALA and DTK and SVM. And the best model is the decisional tree, and the sensor reading for use for the clean versus air pollution, and the system architecture, which is used for the RDMO and Node MCU and cloud and ThinkSpeak. And the summary of this paper, which is mainly we monitoring the real-time data analysis and the model performance comparison. Here we reviewed some paper. The author used some models. They use some paper use the machine learning model, and some paper they use the SVM ML IoT-based, but they had a limitation. They did not use some machine learning DALA model, but we in our paper used all of these things. Here the methodology, we dataset AQI, we set the data section, then it pre-processing for the free section, which is the data normalization, data missing value feature section, and then it is split to the dataset in the machine learning model, which is the LRDT, DA, SVM, ANN, and then it is executing the machine learning model performance, which is then it ultimately the model for the AQI index. Here we can see the data table 1, which is the data city AQI quality, and it is affecting our health. The API is range is 0 to 50 is good for the air quality, and 51 to 100, which is the no health impacts, and API 101 to 150 it is the demonstrated for those for the lungs and the heart disease, and 151 to 200 it is the worst symptoms for the high risk individuals, and 201 to 300 which is the very unhealthy for the increase the reduce the exercise tolerance for those with the heart or the lungs disease, and 301 to 500 is more, it is the hazardous pollution in the endangered health of the worsened symptoms for the severely. And we can see the figure 2 is the correlation matrix for the between the prediction. We can see the Z-score formula used, and in figure 3 we use the time series for the Dhaka city hourly AQI original and the data after mean correlation. We can see the x-axis is the value and the y-axis is the frequency for the red histogram. It is the original data, and the right histogram shows that the mean inputted data, which is the after and before the missing the value handling process. And we can see that this development of implementation, which is started first of all the sensor are the introduced. We previously said that we use the MQ135 and MQ4 and MQ136 are used for this software implementation. The figure 5 shows that the implementation of the our project, which is mainly we set the Dhaka set in the Dhaka city, the biggest garbage area at Shower. We use some machine learning model parameters, which we can see that the mean square error and the root mean square error. This formula we used in our paper. The result and discussion. We can see that table 2 is the 5 machine learning model parameters we can use for the best result for find the DA and DT, and the lowest performance we can find the SVM, which is the support vector machine. And we can see the figure 6, which is the actual versus predicted APY graph. Here the x-axis is the simple index and the y-axis is the APY, which is the 0 to 900. It is the blue line is the accurate APY and the red line is the predicted APY, which is the sometimes it is dropped and sometimes